Good morning, everybody. Well, it's morning for me when I'm recording this, sorry. This is section 1.6, Introduction to Solving Equations. Now, some of this is going to be a review. Some of it's a little bit different and sort of challenging. At least it can be challenging. So you're all used to solving the equations. The steps that you're doing to solve those equations, they have specific names. There are properties that just kind of, it's like the rules. It allows solving equations to happen. And that's what you're looking at here. They're called properties of equality, meaning if you have two equal things. If you do one thing to both sides of the equation, things stay equal. So, the main ones that we use: addition property, subtraction property, multiplication property, and division property. Basically, they're all the same thing. If you start with two things that are equal, A equal to B. I mean, there could be a bunch of quantities in A, but you got left side equals the right side. Add addition, subtraction, multiplication, and division. If you do the same thing to both sides of the equation, it all stays equal. A equals B, then A plus C equals B plus C. You're just adding C to both sides. Subtraction property, you're subtracting the same number from both sides, multiplying by the same number on both sides, dividing both sides by the same number. Okay? These properties just guarantee that if you start with equal things and you do these steps, you're going to keep the equal things. And down here on the bottom, the substitution property basically just allows you to check your answers. You get an answer X, you go back up top, plug in that value for X, substitute it in, and make sure everything works properly. Okay, so the relationship between, for this example, relationship between Fahrenheit and Celsius is given by that equation. That's probably something you've seen lots of times before. And so just a simple example. Question is, find the Celsius when it is 45 degrees Fahrenheit. So plug in 45 degrees for F. That is 9/5 C plus 32. And we're just trying to solve for C. So the first thing we're going to do is subtract the 32. You get 13 equals 9/5 C. Okay, we got 9/5 times C. You could divide by 9/5, but I think there is an easier way, multiplying both sides by 5/9. So you're multiplying both sides by the same number, everything is going to stay equal. It's the multiplicative property of equality. So 9/5 times 5/9 is just C. 5/9 times 13. 50, that's going to be 65/9, which is just a little bit over 7. We'll call it 7.2 just off the top of my head. I'm not sure exactly what it is, but somewhere around there. 7.2 degrees Celsius. Slightly cold. All right. A literal equation. Kind of a weird name. I've really never heard of it. You don't use it all that often, but that's what it's called. Basically, you just got an equation that contains two or more variables. This equation here is the volume for a cone, 1/3 pi r squared. You got a variable v, you got the variable r. This equation here is the equation for the volume of a square pyramid. So the base is a square, but shaped like a pyramid. It's got three variables, v, s, and h. These are called literal equations. Again, I don't use that term very often, but just an equation, bunch of variables in it. So these are the ones that can be kind of challenging. What you want to do is solve this equation. It's got a bunch of variables in it, trying to solve it for one of those variables. So in this top example, we're trying to solve for this v0, v sub 0. So the idea is, wherever that variable is that you're trying to solve for, get that part of it by itself. Okay, that v0 is in the numerator, so let's get the numerator by itself. So multiply both sides by t. So what we have is ta equals, these t's canceled out, so v minus v0. We're trying to get the v naught all by itself. So what I'm actually going to do is, because it's a negative on the right side here, I'm going to add v naught to both sides. So we got v naught plus ta equals v. Now, subtraction property. I want to get the v naught all by itself. So what we get is v naught equals v minus t times a. And that's it. For this bottom example, so let's solve the following equation for a. Now a is in two different spots. So again, kind of the same idea. A is in this fraction. Let's get that fraction by itself. Okay, this big fraction is being multiplied by d. So if we want to get that fraction by itself, we're going to divide both sides by d. Those cancel out. We're left with this fraction, a over a plus 12 equals c over d. So now what we're going to do is, we've got a fraction equal to a fraction. I'm going to cross multiply. So we got a times d equals c times a plus 12. Okay. I'm going to come up here now. So I'm going to do the distributive property on the right side. AD equals a times c plus 12c. Again, we have two terms with a in them. If we're going to solve for a, we need to be down to one term. So this one's a little bit strange, but I'm going to subtract this AC from both sides. Now, AD and AC are not like terms, so we just got to keep them separate. We're left with the 12c on the right side of the equal sign. Since these are not like terms, the AD and the AC, and we want to be able to solve for a, meaning we need a single term of a or a single value of a, what I'm going to do is factor out an a. This is d minus c equal to 12c. Now this is just a times this quantity of d minus c. We want a by itself, divide by that quantity of d minus c. Those will cancel out. A equals 12c over d minus c. There's that equation solved for a. So you can see, this was a few steps. Some of these problems can be a little bit difficult. Many times you're going to be looking for this type of thing, that factoring. If you've got multiple terms of that one quantity you want to solve for, you're going to have to do some factoring. All right, that is it for this section. I hope you enjoyed it. Have a good night. See you in the morning.